Hello everyone, welcome back. My name is Cytlaly Rodriguez, and today I want to start off with saying that we all make a difference in the world. Why am I saying this? Let's imagine we have a subtraction sign and an addition sign. The subtraction sign asks the addition sign, "Are you sure I make a difference?" And the addition sign says, "I'm positive." All right, everybody, let's get started. Today we're going to talk about Module 2, Chapter 2 sets of and whole numbers, number theories, and Chapter 3, numerations and computations. In this problem, we are to construct a Venn diagram that helps illustrate some letters. Let U equal A, B, C, D, E, F, G, and H, and let A have B, C, D, G, and H. Let B have D, F, H, and C, D, G, H. We are given the letters above to help identify where they belong in the diagram. Let's take a look at the next slide that we have constructed a Venn diagram. Number 1 asks us to find B union C. Since the previous slide, we saw that the sets are given to us being U equal universe and B sets of A's, B, and C. Our first element, we're supposed to figure out where B union C go on the Venn diagram, which look like this, where we have A right here, B union C, so they touch each other right here. So that means they touch. Then we're asked to intersect. We're given A intersecting B, which means A and B are touching, and C, which are located above, A, B, and C. We are to find A union C, right here and right here. Then we have A with a line over it, which means not including, which means that that small A I put right here goes in the universe, but not in those three diagrams. At last, we have A union with B intersecting C, which all it means that all three circles touch each other. That's all that means. And that's the same thing as the letters that were placed inside. All the letters that were in set A are placed here that were not placed in sets B or C. Same thing goes for B. All the letters that weren't in set A or C are placed here. And then all the letters that they combine each other, that they touch and share, are here and here. Moving right along. Above, we are asked to find the missing shapes in the following sets. We are giving L intersecting with H. So the first step we have to take is look at the information given to us. The first clue we have is let C equal circular, H equal hexagonal, and T equal triangle. Let S equal for sets, small sets, and L for large, and R for red, and B for blue. Which, with that being said, we already know that L equals large and H equals hexagonal. Therefore, it has to be the large hexagonals, which are the ones that have a that have a heart in them. That will help us identify. In the next slide, we are continuing to find the given problems. We are to describe the shapes that are given in set C union H. And the answer is easy. Let's look back at our clues. C equals circular, H equal hexagonal, T equal triangle, S equaling the sets of small shapes, L equal large shapes, R equal red, and B equaling blue. The ones with the sun are the ones that are chosen that is the correct answer because they have to be circular and hexagonal. So it's all the hexagons and all the circular ones. So no triangles on this one. In this problem, we are to find the shapes in the sets T intersecting R. And we are given the clues like the same above, which in this clues, it's given to us. We can see that the answer would be triangles that are not red because it's T intersecting R, which means T equaling triangles are being red. So the U is upside down is identified as it cannot be red. So therefore, we would have triangles that are marked with lightning, the ones that are blue. This problem, we are to continue to find the shapes, describing the shapes are in set C intersecting S, S intersecting R. So we look back at our clues, what C, S, and R identify as. The upside U is identified as intersected between C, S, and R, like I said before. In this case, the answer would be circles and small that are in red. That's because C equals circular and S equals small and R equals red. So small, circular, red circles. In this problem, we are asked to explain what an endo-aerobic equation is. In fact, let's take a look above and identify the key to the right. The key to the right helps us identify which symbol is equal to and how to get the correct answer. The first symbol kind of looks like an upside down finger is equal to 10,000. The upside U lets us know that it's equal to 10, like shown on the right. And finally, the straight line is equal to 1. Now that we know what each symbol represents, let's look at our problems given to us. We are given 3 fingers pointing down in the pink, and 5 upside down U's, and 4 straight lines. Like shown above. Okay, so the one to the left, it shows us what our symbols, how many symbols we have, and we have to add that up. If we add all this up, we get a grand total of 30,054, which is each pink finger is equal to 10,000. So we do 10,000 plus 10,000 plus 10,000 plus 10, 10, 10, 10, 10, 10, 1, and 1 gives us a grand total of 30,054. This next problem, we're still finding what is an endo-aerobic equivalent equation. So here we have to figure out what this equation is. We are given a key, what M equals, what C equals, what X equals, what B equals, and what I equals. And this will help us set up how to find our equation and set it up and be able to solve. Well, if we set it up the way it is, that gives us a total of 2,930, which is incorrect. Because this is incorrect, the reason it is incorrect, we have C and M, and the rule is if a C is smaller, goes before M, we have to subtract 1,000 from 100, giving us 900. So this is the way we would set it up in the green, which is 1,000 plus 900 plus 10 plus 10 plus 10 plus 1 plus 1, giving us a grand total of 1,937. Now, that is the correct answer for this problem because of the rule we had to follow. Continue right along, we have to find the grand total of the given symbols. Again, the first thing we have to do is find the key given to us. We are given a key. The key helps us identify what each symbol is equal to. The less than sign is equal to 10, and the upside down triangle is equal to 1. Question number 3, that is what is given to us. That is the sequence we have to identify. we look to the right, and we are given 4 less than signs and 1 upside down triangle. Next, since our handy dandy key is given to us, all we have to do is set it up to equation and figure out the total. When we add 10 plus 10 plus 10 plus 10 plus 1 gives us a grand total of 41. With the key, it's super easy to figure out what our grand total is. Next, looking at the problem above, we are given the problem of the symbol. Again, those symbols are made to in a chart with a key. The symbols are placed right at the top and what it's equal to at the bottom. So it just helps us keep it in order. This makes it easier on both knowing how to find what the symbols are equal to and helping solve the problem. If we take a look above, we can see each symbol is identified. And now if we add up, we have to start from the top to bottom. It states the rule is starting from top to bottom, it's 7,200, 360, 20, and 1. So it starts from left to right. So we would have to do 5 times 7,200, and then 6 times 360, and then 3 times 20, and 17 times 1, which gives us a grand total of 38,237. So the only thing we have to do is, we already know what this symbol is equal to, which is 5, and this one, which is equal to 6, and the 3 dots equal to 3, and the 2 dots and 3 lines, which equals to 17, which is a big help. So all we do is take those numbers where these go in, and since the rule was start from left to right, with 7,000, the first row being 7,200, the second one 360, and the third one being 20, and then 1. And all we do is set it up like this, and we get a grand total of 38,237. Now let's do the fun part. We are asked to figure out the lattice multiplication table. First, we have to set it up. Our first problem asks us to multiply 28 by 32 by using the lattice multiplication table. So 28, so the 2 and the 8 are placed at the top table from left to right. Then we place the X, and on the right side going down, we place 3 and 2. Now that it's all set up, we're ready to continue. To solve it, we would work from the 2 to the bottom. So in other words, we would do 2 times 3, which gives us 6. And then we would do 2 times 2, which would give us 4. And then we would go to the A and work down. So 8 times 3, which gives us 24. And 8 times 2, which gives us 16. Now that that is all figured out, we will work from the blue arrows down. So 0 right here, 6 plus 2 gives us 8, and 4 plus 4 plus 1 gives us 9, and the 6 stays here. Therefore, our grand total will equal 896. This is a new version of math, which when I was growing up, we did it totally different. This is pretty neat. It's pretty fast and pretty convenient and pretty handy. Now, let's take a look at the second one. We're continuing to figure out the lattice multiplication table. We are given the numbers to multiply 273 by 68 by using the lattice multiplication table. We place the 2 at the top, starting from left to right, same thing we did before, the 7 and the 3. We place the X because we're multiplying on the side on the right going down, the 6, the 2, and the 8. Now that we have that, we do the same thing we did before. But now, since we have 3 numbers, we start from 2 times 6, which gives us 2 times 6, which gives us 12. We have 2 times 2, which gives us 4. 2 times 8, which gives us 16. Now, moving with the 7 right along. 7 times 6 is 42. 7 times 2 is 14. And 7 times 8 is 56. Now with the 3. 3 times 6 is 18. 3 times 2 is 6. And 3 times 8 gives us 24. Now that that is completed, the next thing we have to do is just follow our arrows down, the same thing. We just follow them down. With that being said, we get 1 starting from the top, going to the bottom. First arrow going, working our way down. 2 plus 4 plus 1, 7. 1 plus 4 plus 1 plus 2 plus 1 plus 2 is 4. 6 plus 5 plus 4 plus 0 plus 8, and our carried 1, and we work it all the way down, getting a grand total of 171,444. So if we start from this way, and 6 plus 6 plus 2 is 14, we put our 4 here, and we add it to the next line, and we add like that, and we continue. So 8 plus 1 plus 4 plus 5 plus 6 is 24. We carried our 2, and then we just continue. And that's how we end up with a grand total of 171,444. Let's look at this one. The same thing. We're asked to multiply 964 by 593. So the first thing we have to do is start at the top, placing our numbers from left to right. We do 964 times 593. And we work it the same exact way. We do 9 times 5, which gives us 45. We do 9 times 9, which gives us 81, and 9 times 3, which gives us 27. Now we go to the middle and work this one. 6 times 5 gives us 30, 6 times 9 gives us 54, and 6 times 3 gives us 18. Now 4 times 5 gives us 20, 4 times 9 gives us 36, and 4 times 3 gives us 12. Now that this is all set up, we do the exact same thing. We're going to follow our green arrows. We follow all 6 of them down to get the grand total. Now instead of starting, let's start from the bottom. So we'll start here. So with this arrow, which gives us 2. Or we can start up here, which gives us 5. And then 8 plus 5 plus 3 plus 1 gives us 17, and we regrouped, and we get a grand total, continuing down, we get a grand total of 571,652. How do I know this? Same thing, we work from here to. From here, we regroup, we get that answer, we regroup, we get that answer, we regroup, and we just literally go from left to bottom, making like an L, and 571,652 is our grand total. Now, we are giving the last problem to multiply 4,952 by 243. So we place our 4, our 9, our 5, and 2, our X, our 2, our 4, and our 3. With that being said, we work our problem, and we get first box, 8. 4 times 5 gives us 20, and 4 times 3 gives us 12, 4 times 9 gives us 18, 9 times 5 will give us 36, and 9 times 3, which gives us 27, Moving along with the 5. 5 times 2 is 10. 2 times 5 is 25. 5 times 3 is 15. Now our 4. 4 times 2 is 8. 4 times 5 is 20. And 4 times 3 gives us a total of 12. We follow our yellow arrows and get a grand total of 1,203,336 as our grand total. Isn't that crazy? Now, let's take a look at rounding off. Above, we are asked to round off and demonstrate how to round off. We are given the problem 883 plus 465 divided by 134. Let me show you how to solve this problem. The first thing we have to do is add 883 plus 465, getting 1,348. Then we take 134 and square root that by 1,348. We continue to solve, and we notice that 134 goes into 1,348 one time. So we put the 1 up top, we solve, we bring down the 8s, and we bring down the 0, and coming to a conclusion, which our grand total is located right here in the red of 10.05. But since we are asked to round off, we would, and the 5 is greater. If it's 5 or more, you round up. If it's 5 and less, you leave it the same. So that would round 10.05 would round up to 10.1. The next problem we're asked to solve the given problem, rounding off as well. We have 5 times 254 plus 523 divided by 35 plus 7. The same thing. The first thing we want to do is figure out what 5 times 254 plus 523 gives us 1,793. 35 plus 7 gives us 42. And then we see how much 42 goes into square root of 1,793. The first thing we notice is that 42 goes into 42 right here. We subtract 168 and we get this, and then we bring down and we carry all the way until we get to the bottom, and we have 42.690, I'm sorry. And since the 6 is bigger than 5, we round up, so that makes the 2 go up to a 3, making it to the grand total being around 43. Our next problem, we are asked to round off once again. When we round off, we're rounding off 620 times 430 divided by 293. If we do 620 times 430, we get 266,600. And we divide it by 293. We set up 293 with square root of 266,600 and square root that. When we end up solving and figure out the problems and carrying and regrouping and all, we get 909.709. Since the 7 is greater than 5, we bump the 9 into a 10, and that makes it to 910. Above, we are given 2 problems to help find the base 5 that are located at the top. We are finding the basis of 5 and 6 using addition. Let's take a look above. We have 432 plus 133, and we have to add that up. Well, the rule of base of 5, we can use any number from 0 to 4, meaning 3 plus 2 equals 5. We have to place a 0 and place the 5 at the top and place the 1 above the 3. Then 3 plus 3 is 6 plus 1 equals 7. So we asked ourselves, how many times does 5 go into 7? And it is 2, so we carry the 1. We continue the sequence and get a total of 1,120 with the base of 5. With problem number 2, we have 628 plus 73. Now that we have the base of 6, where it can be anything from 0 to 5, we add 8 and 3 and 1, and we ask ourselves how many times can 6 go into 11? And we get 5, which is left at the bottom, and carry the 1. And that's how we continue we continue the same sequence and borrowing and get a grand total of 1,145 with the base of 6. Now, let's find the basis of 5 and 5 using subtraction. We are given 414 minus 43. This is the exact same sequence, the exact same steps, except the only difference here is instead of addition, it's subtraction. So what we're going to do right here is we ask ourselves 4 minus 3, which is 1. We leave the 1 at the bottom. We can't subtract 1 minus 4, so we have to borrow from the 4 and make the 4 a 3, and make this 11, and then subtract and get a grand total of 311 with a base of 5. Now, let's take a look at this last problem. It's 503 minus 24. Same thing. 3 minus 4. 3 is smaller than 4, so we have to borrow from the 0. The 0 now becomes a 9. 13 minus 4 is 9. And then we continue to work our way down. 9 minus 2 is 7. And then just bring your 4 down, making a total of 479 with a base of 5. Thank you everyone for watching this video. I hope everyone learned some new techniques about math that are being used nowadays. Bye.